Starting from the version 1.6, we have a new fracturing tool named mesh slicing that will allow us to break the objects into multiple ways. Let's get started. The mesh slicing is located in the Split tab. The old functionality is grouped in the shell splitting panel. As you can see, it's composed of 3 sections. The first one is where you input the mesh. You want a fracture. Let's choose the cube. The second section is where the fracturing happens. Those are the presets. We talk about them later. To add a new cutter, use the plus button. Those are the properties of the cutter we just added. If we hit execute, we will get the slicing result. As you can see, it's an array of cutters along the x-axis. We can change the orientation to y, but then you will need to change the z rotation 90 degrees, and then hit execute again. We can also change the orientation to z, but then we would need to change the y rotation 90 degrees, and then hit execute. To change the number of cutters, just change the count parameter. To change the distance between the cutters, change the offset parameter. And to make the distance random, increase the randomized parameter. Every time you change the random seed, you will get a different result. And you can enable randomize to get a different random seed every time you hit execute. The position parameter is to move the cutters along the specific axis. In this example, it's the x-axis. 0 is basically the center of the object. If we change the scale of the source object in edit mode, and then hit the execute button, you can see the 10 cutters are evenly distributed. But if it was disabled from the relative option, the cutters would be distributed according to the absolute dimension. It's useful when creating the presets, because different objects have different dimensions. It's possible to randomize the rotation of the cutters. Just by randomizing the Y rotation, we will get some interesting results. And by randomizing the Z axis, the result is even more interesting. When happy with the results, don't forget to disable the randomization parameter. It's possible to give the interior faces a different material than the exterior ones. To do so, just change the material to 1, or whatever is the index of the desired material. And make sure you have enough materials on the source object. Then hit execute. The global offset affects the offset of all the cutters. The last section is the output mesh. From here we can preview the charts. There is also a handy operator to check the number of charts. You can, for example, increase the global offset to reduce the number of charts. Once you are happy with the result, you can hit the apply button, give the new collection a name, and then hit OK. And all the charts will be converted to individual objects, ready to be animated. As you can see, we can get some pretty cool results by just using one group of cutters. The real power of this tool is when combining multiple cutters. We will use the same cube as the source object. I will add first the cutters, and I will name it X. Then I will add a second one along the Y-axis. And we can add a third along the Z-axis. And we have this cube's pattern. Actually, we have a preset named cubes. To load a preset, just press the button next to the list. Then don't forget to hit execute. We have another preset named pie. It's like a sliced pie. You can add slices on top of the preset to create your own patterns. The pyramids preset is interesting, but it's heavy. You can increase global offsets before executing for faster execution time. You can study the presets to get an idea how they were made. Fracturing the cube was easy. Let's try a more complicated object. Well, we use this model that I downloaded from clara.io. The first thing to notice is that the origin is not in the center of the mesh. That could cause problems later, because the add-on considered the origin as the center of the mesh. So I will set the origin to the geometry. Now let's set it as a source. The add-on gave us a couple of suggestions. The first is to apply the scale. I will scale down the object to a dimension that makes sense. One thing to notice is that the Y dimension is bigger than the Z dimension, which suggests that the local axis is not aligned with the global axis. If we change the orientation to local, we can use the local Y-axis is pointing. Just keep in mind that the add-on distributes the cutters along the local axis. We will start by applying the scale. Just press Ctrl plus A, then select scale. And for the rotation, I will change it to XYZ Euler, because Animax uses only this type, and then I will press Ctrl plus A. Then select rotation, and the transform is ready to go. We will ignore the second suggestion for the moment. I will use the cubes preset. And it worked as expected. But if we disable the preview, we can see the shading artifacts. And that's what the second suggestion was about. To fix the problem, just enable Auto Smooth in the source object, then hit execute again. Now it's just a matter of time of playing around with the parameters until you get something that you like. One last thing to notice is that there is a feature and a limitation in the same time with this fracturing method. If we fracture this model, you can see that at the bottom there are some artifacts. That's because the original object contains gaps. The self-fracture add-on would fail with this model, but Animax will try to fill these gaps. The problem is, it sometimes will fill some areas that are not supposed to be filled. Let's use a text to demonstrate the problem. We'll need to convert it into a mesh. Enable Auto Smooth. In the mesh output, I will remove the object, so that the add-on will generate a new one. And finally, I will apply its rotation, and set the origin to the geometry. If we try the cubes preset, we will get a lot of problems, because there are overlapping doubles. Enabling remove doubles will solve most of them, but we still have the first A. To fix this problem, we need to change the order of the cutters and put the Z first, and it worked. But why did it work? Because we need to put a perpendicular cut on the holes first to tell the add-on to fill the gaps. That's why the Z cut first fixed the problem. That's it for today's video. Thanks for watching.